Black Dot. Welcome in blocks 2G and 4G. We're coming to you live from block 4W today. It's a great day to be here. We got Q Cowie, we got McKenna Goodson in the house, Kendra Pierce, Caitlin Hutchinson, Anna Stanley, AJ Crumnow, everybody. Pip Williamson, AB, Alex Bratton, Rogan Brashear, Reagan Cox, Grace Wittenberg, and Gwendolyn Smith, Gwen Smith. So that's who we have today. I need everybody to take out your note sheet that we did the other day, which I said we wouldn't have to finish, but guess what? That might have been a fib because we have to finish it today. So take out your 9.1 notes from the other day. And while you're getting that out, I would like to welcome you to pre-calculus today. It's a great day to have a great day. Have an attitude of gratitude. Be a winner, not a whiner. Get better, not bitter. I'm going to have my great friend Gwen Smith read the top paragraph from the notes that we did not finish the other day, and then this is going to propel us into our new lesson for today. Gwen, take it away, loud and proud. Here we go.
An equation expressed in terms of polar coordinates is called a polar equation. For example, r equals 2 sine theta is a polar equation. A polar graph is the set of all points with coordinates r, theta that satisfy a given polar equation.
Gwen, that was outstanding. I'm not going to lie. That was an outstanding articulated reading with great semantical tone and presence. I'm going to offer you a starburst for that reading right there. Up. Love the hair, Gwen. All right, now, next paragraph. Read along with me, everybody. You already know how to graph equations in the Cartesian or rectangular coordinate system. Graphs of equations involve constants like x equal 2. By the way, is that a vertical or horizontal line? X equal 2. I got to vote for vertical. Yeah, it's vertical. That's a vertical line. And then you know all your y equals are horizontal lines. So similarly, the graphs of the polar equations r equals some constant or theta equals some constant, where k is a constant, are considered basic in the polar coordinate system. Let's just consider r equals 2. Well, all that means is you're going to circle 2. And let's mark off our circles here. Let's go every other one. Let's go 1, 2, 3. I want you to label those 1, 2, 3, 4. Let's go every other one. All r equals 2 means is you're just highlighting the whole circle. You're highlighting the whole circle. That's your graph. R equals 2 is circle 2. It's circle 2. Boom, there's the graph of r equals 2, if you want to label it there just for reference. How would I graph theta equals pi over 3? Theta equals pi over 3. You know how I'm going to graph it? I think somebody in this class is going to tell me how to graph it. What shape would theta equal pi over 3 equal? Right there is pi over 3. How do you like graph pi over 3? What? It's the whole line. That was Anna Stanley, everybody. That was Anna Stanley. It's the whole line. Ooh, optical illusion here. Oh, where is it? I think it's this one right here. Yep, it's the whole line, and that is theta equals pi over 3. So r equals are circular graphs. Theta equals are straight line graphs. Go ahead and graph theta equals pi over 6 on your paper, and well, that's another straight line that goes right all the way through here. So with that in mind, with those things in mind, let's go on to our new stuff today. I don't have a note sheet for you. I'm going to explain today's new stuff we're going to do the first 2 problems in your assignment together. You have 8 problems for your assignment. By the way, that last one was theta equals 5, 6 pi. And I'm not going to do another r equals because you know what it is. It's just a circle. So I'm going to do the first 2 problems in your assignment with you. It's an 8-problem assignment. We do 2 of them together. That means you have 6 problems due for White Day next Monday, Green Day next Tuesday. So let me close our notes out. I do not want to save that. And let's take out the sheet. If the substitute teacher has not passed these out yet, you need a 9.2 graphing polar equations assignment sheet. And we're going to do the first 2 here today. You should also have somewhere, I know I have it somewhere, you should also have a half sheet. Did I hand out a half sheet? You should have the unit circle at your disposal, a half sheet, and then I need some major, like, Pizza King gift cards for this. I printed out some T-tables so that you would not have to create these T-tables every time. That will save you some time. So your assignment is from page 548. Let's just give a quick look at page 548 and see what number 1 is in fact. We have to graph r equals negative cosine of theta. Negative cosine of theta. Let's put that right on top of our first T-table. We're going to graph r equals negative cosine of theta. So I'm on the T-table. What does the graph of negative cosine of theta look like? Well, look up at the screen. Our natural ordered pair for polar coordinates is r comma theta. I've kind of flipped that because I felt the T-table went a lot smoother when I plugged in my theta values, and then we were kind of getting r as an output. So I kind of flipped these around, but just note that really your ordered pair is r comma theta. Well, why don't we just plug in, I'm going to start here at 0, and notice we're going to plug in different values of theta all the way around the unit circle. Which ones are we plugging in? Well, I'm going to start with 0, which is right here. I picked pi over 6 as a good plug-in. Then I skipped pi over 4, because let's face it, Q, it's going to get a little mundane if we plug all 12 of these in. So I picked pi over 3. I picked pi over 2 because it's just a great one to pick, because it's kind of easy, because it's just 0 and 1. We're going to plug in 2/3 pi. We're going to plug in 5/6 pi, and we're going to plug in pi. And we're not going to go around the bottom half of the circle, and I'll show you why in a second. Okay, so those 6, yes, you got to be patient. Let's do it. Let's plug in 0 first. And you might have to write tiny, because I didn't really leave much room until you scrunched over into the next T-table. But, I hope this goes well today. Will somebody tell me what the cosine of 0 is? A 0-degree angle. What's the cosine of 0? And I'll have somebody from the audience shout that out when they get confident. What do you have, 4Dub?
1.
The cosine of a 0-degree angle is the x-coordinate, which is simply 1. But there's a negative sign in front of it, and so it's negative 1. So our ordered pair, dadgummit, I didn't leave enough room. Our ordered pair that we are going to plot on our polar graph today is going to be, now turn it around, so put the r first. So I just found r, negative 1, comma, 0 degrees. That's my first point on my grid. I think we'll just go through and do all the T-table first, and then plot the points at the end, instead of going back and forth right now. I also want to find, and write scrunchy now, I also would like to find the negative cosine of pi over 6. Well, what is the cosine of pi over 6? Ooh, this just got a little nasty all of a sudden. So it's rad 3 over 2, but remember we have a negative sign, so negative rad 3 over 2. I want decimals today. What is, do you have a calculator? What is rad 3 over 2? Yeah, let's round to 1 decimal place, please. The square root of 3 divided by 2 is 0.866 blah, blah, blah. Now, if we have to do something to that, like multiply it by something, you will keep that decimal in there. We won't round it to 9. But if we're done with it, like all we're doing is making it negative, then yes, just negative 0.9. So the point we're going to plot is negative 0.9 comma pi. Oh, look what I can do. Look what I can do. Look at this. Oh, this is beautiful. Look what I can do. I can use the next t-table to, now you don't want to do this because you're going to need these t-tables for your assignment, but I can use the next t-table to beautifully, life is full of simple little joys and pleasures. All right. What about the cosine of pi over 3? What's the cosine? I'm going to call on so many great people in here, Green Day Nation, but I'm going to call on Anthony A.J. Crumnow, whose Clippers did, in fact, defeat the Golden State Warriors at Golden State last night. It's 3-2 going back to L.A. Look out, everybody. This could get interesting. AJ, can you locate the cosine of the pi over 3 degree angle for us?
That would be 1.
That's AJ Crumnow, everybody. It's 1/2, and so it's actually the negative 1/2. And so the plot, or the, so we're going to plot negative 1/2, comma, and again I'll recycle the pi over 3. And now we're up at the pi over 2 angle, and so what's the negative cosine of pi over 2? Well, the cosine of pi over 2 is 0, so it's negative 0. So that's a big fat 0. So I'm going to plot 0, comma, pi over 2. And yes, at this point it gets to be a little mundane. You got to go through the rest of the circle, but it's okay. We just have to have a positive attitude. What is the cosine of 2 pi over 3? This one is for Caitlin Hutchinson, everybody. What is the cosine of 2 pi over 3?
Negative 1/2.
Ooh, it's negative 1/2. So it's negative of negative 1/2, which is actually positive 1/2. So we're going to plot positive 1/2, comma, 2 pi over 3. And there starts to be a little symmetry here. You'll catch on to this after 2 or 3 of these. It took me 2 or 3 of these to kind of catch on to the symmetry. But now we're going to plug in 5 pi over 6. The cosine of 5 pi over 6. Kendra Pierce in the house. What is the cosine of 5 pi over 6? Rad 3 over 2. Well, it's negative though, isn't it? And you might have said that, or maybe you already applied the double negative. But yes, it's negative of a negative, and so we are going to plot positive rad 3. No, I need that decimal. That's another 0.9er, isn't it? Yeah, let's go decimals with these all day. 0.9, comma, 56 pi. And then lastly, I am going to take the cosine of pi. AB, what are we looking at for the cosine of pi?
That would be 1.
It would be negative 1. However, it is negative 1 of negative. It's a negative of negative 1. So your final answer is in fact correct. It's 1 comma pi. So, like Pippin mentioned earlier, we're going to plot these, basically 7 points, and connect the dots, and you will have graphed a polar equation. It's a simple equation, but it is our first equation ever that we did together. It's a happy moment. So, do you have your assignment sheet, number 1? Where is -1, 0 degrees? And by the way, I've helped you on your assignment. I've numbered off. I did all these, so I numbered off the appropriate amount that I felt would help you. However, what did I do with mine? Hold that up. Caitlin, let me see what I counted off by. Where did I count? Where's my 1 at?
It's halfway.
Yeah, halfway. Okay. So I went 25, 50, 75, 1, 0.25, 0.50, 0.75, 2. All right. So there's my first concentric circle. I'm just going by 4s. Okay. So what are we graphing first? We're graphing -1 on the 0 degree line. Somebody talk to me about that. Anna.
It would be on the 0 degree line, just to the left of the.
Yes, out the other side, exactly. And we don't really even put negative over here. We still have everything positive. It's not really -1, it's +1. It's just polar coordinates are just going out the other side. So, yeah, so it would be right here. I'm going to put that in black. I'm going to put that in blue. Blue. So I just plotted the point 0 degrees, -1, which goes out the other side. Oh, what did I just do? I didn't want to do that. Oh, get over there. Oh, I'm getting seasick. All right, is that where I wanted to go? Okay. That's 3. I'm on 3. What did I do wrong? 1, 2. No, I'm on 4. Reagan, how do I graph -0.9 comma pi over 6? Okay, right here. Yes, yes. Just shy of 1. It's -0.9, so just shy of 1. So about there's my 1 circle, right? There's my 1. So about, I don't know, 0.9, about right there. About right there, maybe. Just shy of the 1 circle. 0.9 is just shy. All right, so I'm on the pi over 6 line, out the other side because it's negative, and 0.9. Now, Rogan, Brashear, where is, tell me about -1/2 pi over 3. Got it. Okay, and what was the decimal, or what was our? Oh, that's just half. That's 0.5. Okay, so -0.5. So go about halfway out to your 1 circle, which is 1, 2. 1, 2. What is this going to be? Is this like a black hole? Is this like going to go all the way down that chute there? Wow. I don't know. We'll see. All right. Oh, I love the next one. 0 comma pi over 2. 0 comma pi over 2. I'm on the pi over 2 line, which is the straight vertical line, and it's 0. So it's the origin. It's nothing. It's at the origin. It's at the origin. It's on pi over 2, and it's 0. And then how about 1/2 comma 2/3 pi? There's the 2/3 pi line, and now it's positive 1/2. So you're going halfway to the 1 ring, halfway to the 1 circle. It's positive 1/2. So now go up toward your angle. Oh, I think I know. I think I got it now. I think I can see what's going on here. How about 0.9 comma 5 pi over 6? Let's get on our 5 pi over 6 line and go almost out to 1. Almost out to 1. Almost out to 1. Almost out to 1. And then I'm guessing that the last one is 1 comma pi. 1 comma pi. That's on the pi line, and it's out to 1, which we already started with. What do we have here? We've got a perfect circle. That's not a perfect circle. That's like a hexagon. Yeah, I just started a perfect hexagon, but it really should be a circle if you can kind of do some curvy curves to it. Do some curvy curves if you can. Just kind of round it off. It is a circle. Yep, it's kind of a cool little thing here, entering into some calculus type of shapeology. All right, so there it is. There's a circle on the polar coordinate plane. If you did the theta values down below here, they just fall on right on top of these points. It just gives you another circle. So all day today, you don't have to do the bottom coordinates. Just do the ones I have on the T-table, and that'll give you your shape. Woo! What do we think of that? What do we think of that? I need a question right now about something. Somebody has to ask a question. I just looked in the back of the book and it was a circle. So I just assume we're just doing a circle. Yeah, we're just kind of circling it off. I really don't know much theory behind it, Pip, at this point.
I'm guessing if you did more defined points, it'll form a circle.
Like,
Oh,
add more
oh.
points on it.
If we did the points in between, which I skipped,
Yeah.
I bet they're right here, and that gets your circular shape.
Yeah.
Gwen Smith, everybody. The book left out those points. They did the points that we did, so I climbed on board with that because I'd rather do 6 than 12, which I know all you would as well. So just go with the circle today. Just go with it. Don't overanalyze it. Okay. Now, okay. So there's of the 6 that you have remaining, 4 of them are like that, I believe. 4 of them will give you maybe some circular options, but I still want to see your work. The other 2 are funky. Let's do number 2, and then I'm going to get you on your way, and you can have the rest of the half. You can have the rest of the block to work on the remaining 6 graphs. Okay, so get a new T-table. I'm going to erase all this. Hope my 2G nations are doing well, sitting patiently watching this video, and I hope this will put you in prime position to succeed on the homework. But what is a number 2 on our homework? It is, hurt me. R equals cosecant of theta. R equals cosecant of theta. All right, so R equals cosecant of theta. Green day, when the bell rings, you may take your break today. White day, we're going to just, for the fluidity of this video, we're going to stay in here, and then we'll do just college-style bathroom if you have to after this video. So I'm just going to keep cruising with it when the bell rings, okay? Was that a pre-calc stretch or a hand up back there? Is that a stretch?
Yeah, it was a
All right. Okay, so let's go for it. Now, wait, a cosecant. I can't really get cosecant of any angle out here, so it might be prudent of us to change cosecant to 1 over sine theta. Yes, let's use 1 over sine of theta. All right, so let's plug in 0. What is 1 over sine of 0? Well, back to Reagan Cox. Reagan, what is the sine of a 0 degree angle here? Sine now. So that's it's 0. It's the y coordinate. It's the sine of 0. Oh, wait, that puts a 0 in the denominator. Undefined. We're not going to be able to graph that one. Can't even graph that one, so don't worry about it. Yeah, if you get a 0 in a denominator, just don't worry about it. Let's go on to 1 over sine of pi over 6. Q, are you ready to partake in the ceremonies today? Or are we, what's the sine of pi over 6? Can you just glance up here and tell me what the y coordinate of the pi over 6 angle is?
Is it 1 over 2?
That is Q Cowie, everybody. He's a legend. And so we have 1 over 1/2, which is basically just 2. Yeah. Multiplied by the reciprocal. And so you're going to plot 2, comma, pi over 6, if I might borrow the other T-table again. Alrighty. Stop me at any time, even though we're videotaping. White Dub or White Nation, go ahead and stop me at any time if we have a question. We definitely want to get this done. White Nation. Sounds rather discriminatory. White Nation. The White Nation. How about 4-Dub Nation? 4-Dub Nation. All right. How about 1 over the sine of pi over 3? 1 over the sine of pi over 3. I'm going to go to everybody's good friend, Kendra Pierce. Kendra, what is the sine of pi over 3? Yes, it is. And if we flip that bad boy around, that would be 2 over rad 3. Now, before we get all bent out of shape and, oh, I've got to change that because I got a radical. Actually, all I want is I just want the value of that. You can just take in your calculator. You can just divide 2. You can divide 2 and divide it by radical 3 and just get that decimal. That's really all I'm interested in is that decimal right there. So that decimal is, somebody, to 1 decimal place. What do you get? 2 divided by rad 3 is 1.2. So we're going to plot 1.2 comma pi over 3 on the pi over 3 line.
Did you cross multiply to get 2? Like, how did you get 2 over? rad 3?
1 divided by rad 3 over 2 is the same as, if you flip it, 1 times the reciprocal, which is 1 times 2 over rad 3. Oh yeah, you could actually put this all in your calculator. Good point. 1 divided by rad 3 divided by 2. Did you have to put parentheses to kind of keep that, or did you just go straight 1 divided by rad 3 divided by 2? Maybe it works. Try it, however, you got to get 1.2 as your answer. Good. How about 1 divided by the sine of our good old pi over 2 angle up there? And the sine of pi over 2 is actually 1, because we're talking y coordinates here now. So the sine of pi over 2 is 1, so that's 1 over 1. So 1 comma pi over 2 is what we'll graph. And we can continue this. You'll see some symmetry here showing up pretty soon. We're over to the sine of 2 pi over 3. And I will tell you right now that the y coordinate of 2 pi over 3 is rad 3 over 2, and we're going to get the same answer as we got for the pi over 3, aren't we? Flip it, you get 2 divided by rad 3, and that's just going to be 1.2 again. And then lastly, it's 1 over the sine of, all I'm doing is I'm just plugging these values in for theta. All those values I have typed in for you, I'm just plugging those in. Sine of 5 pi over 6 is 1 over 1/2 again. 1 over 1/2, which is 2. 2. And what is 1 over the sine of pi? 1 over the sine of pi. The sine of pi is 0. That's another 0 in the denominator. Can't do it. Can't do it. So we really only have 5 points to plot here. 5 points to plot. Well, let's plot them. Let's see what happens. How did I count off on this particular graph on your paper? Somebody hold that up for me. Caitlin, what do I have? Where's my 1s and 2s? Okay, so I went 1, 2, 3, 4, and then 1, 2, 3, 4, 1, 2, 3, 4. Okay, so I'm plotting 2 comma pi over 6. 2 comma pi over 6. So I'm on the pi over 6 line, and I'm going positive 2, up to 2 right there. There it is. I'm on the pi over 6 pole, and I'm plotting 1, 2. That's the 2 circle. Yes! How about 1.2 comma pi over 3? Ooh, how about 1.2 comma pi over 3? Here's the pi over 3 line, and I got to go 1 point, okay, eyeball it. 1 point, about there. About there. 1.3. I thought it rounded to, it's 1.2. Why did I say 1.3? So that might lower it just a skosh. So 1.2. 1.2, okay. Because the next line would be 1.5, so. All right, what was the next one? 1 comma pi over 2. 1 comma pi over 2. So I'm on the pi over 2 line, and I'm just going to the 1 circle. Oh, wait. Whoa, what happened to my circle? What's this graph? I just shot my circle out of the whole universe there. Huh, what's going on there? Well, let's keep going. How about 1.2 comma 2/3 pi? 1.2 comma 2/3 pi. I'm on the 2/3 line, and 1.2 is about right. Oh, I see what I have now. I see what we have. I got it. Yeah. Yep. And then the last one. 2 comma 5 pi over 6. 2 comma 5 pi over 6. What did we just graph? A line. A straight line. You might get a line today. You might get a straight line. Yep, you just graphed a line in polar coordinates. Okay.
Is this like 2D or is it actually like 3D?
Well, that's a good question. I said the other day this looks like Luke Skywalker's laser shot into the Death Star. It kind of looks like it's. I don't have that info. I don't. I don't have that in my toolbox right now. I don't know if this is 2D, 3D. I think it's 2D. I think it's 2D, but wow, could that get exciting if it went 3D in calculus, which I think it does. I'm pretty sure, if I remember back to the day, that's been so long, but anyway, okay, hey, Green Nation, there we go again. 2G and 4G Nation, thank you for your attention. I hope you have a wonderful day, rest of your day. You may work together, I don't care. Don't drop any F-bombs for the sub. And let's use our manners, and your assignment is 3 through 8. 3 through 8. Signing off.